Hello guys and welcome. I hope that you're having a good day or good morning or good evening. My name is I play 4K, AK, I play AK, AK, I play 16K or UHD King. During this video today I'm going to show you Call of Duty Modern Warfare 2 running for the first time. This is world's first 16K resolution render of Call of Duty Modern Warfare 2, and today I'm using the Titan RTX video card and the old school Xeon E5-2697 V2 CPU that comes with 12 cores, 12 physical cores. With the hyper threading technology becomes 24 threads or 24 virtual cores in Windows 10. Keep in mind that this is the old school CPU from 2013, and the purpose of this video is to show you how the game runs 16K resolution on my workstation with the Titan RTX with the old school CPU. Keep in mind that I'm also going to record the video 16K resolution on Modern Warfare 2 running on my gaming PC, which is i9-9900K overclock at 5.3 GHz with Titan RTX. The purpose of this video is not the gameplay. The purpose of this video is to show you how well Titan RTX can handle 16K resolution with 24 GB of VRAM, and so we can bench it with the future technology, with the future video cards, with the future CPUs, and find out how the technology progressed, okay, over the time. So as you can see, I have the stats at the right top corner. My desktop is also set at 16K resolution. So how I achieved the 16K resolution? I'm using 16K resolution on the 8K resolution native screen plus DSR, and it's rendering 16K resolution, and then it downscaling to 8K resolution, but it's still rendering 16K resolution. This is exactly what it takes to take 16K resolution. It's not upscaling to 16K resolution, it's rendering 16K resolution and downscaling. Okay, upscaling and downscaling, there's two different things, and it's starting with a 16K resolution, rendering that amount of pixels, which is 133 megapixel, and then downscaling to 8K resolution. So it takes that type of performance, as you're going to see at the right top. Same thing as we're going to run it on a native 16K resolution screen. And as again, I'm not using third-party DSRs, I'm using the Nvidia native DSR 16K resolution, which I believe the best and as close as possible. Here maybe slower or faster than native 16K resolution render on the native screen, okay? Because Nvidia knows exactly how to bring that resolution. So this is what I'm going to show you during this video. I'm going to show you a couple presets, couple scenarios. So right now, as you can see, everything maxed out, but anti-aliasing is off, okay? Titan RTX right now running completely stock. Let's go ahead and have a look how it's going to run at stock first. As again, the purpose of this video to benchmark. The purpose of this video is not to demonstrate you a gameplay or something like that. Keep that in mind. I haven't played this game for 5 years. It's beautiful. I cannot believe that Titan RTX can handle this game, and it's almost playable scenario. Most certainly it's benchable, as you can see. As again, this is stock, right? Let me go ahead and overclock the Titan RTX actually. In the end of this video, guys, I'm going to show you what kind of computer I was using. But pretty much during this video, I'm going to explain it to you as well. But in the end of this video, I'm going to demonstrate you as a fact. So let's go ahead and overclock at 1000 megahertz additional on the VRAM. So from 14,000 megahertz, it's going to bring it to 16,000 megahertz and 100 megahertz on the GPU. Okay. Again, I just use the zoom tool. As you can see, the Call of Duty Modern Warfare 2 running in windowed mode, and it's very important when your desktop is set to 16K resolution as well, plus the scale at 100%. Okay. You cannot use the scale 500% because if you're gonna do that, it's going to show you a higher FPS count, and it's not going to be right. Keep that in mind. I'm coming in real time. This video is not going to be edited. This is one shot, one take. Hopefully guys you enjoying that, because I certainly do. Okay. Beautiful. It's running nice. And overclock gave us some performance, as you can see, guys. So pretty much it's running like 22, 23 FPS without the overclock, and with the overclock it's additional almost 5 FPS. Keep in mind that I'm recording this video with Nvidia Shadow Play. Okay, so please add 4 FPS to the FPS counter. This is exactly how much FPS it took through Shadow Play on this computer while running this particular game and recording it on the same time on the same computer in real time. Wow, 33 FPS, not bad. So I would say this is a playable, of course not for online, not for the competition, but at least you can play the single player and enjoy. Guys, please watch this video on 8K resolution monitor. Switch it through the YouTube video player to 8K resolution, as again Nvidia Shadow Play was hacked. Width and height of the recording video container was replaced to, instead of 4K resolution, to 8K resolution through the system RAM debugging tool in runtime, and it's doing it without any issues, only 4 FPS. So pretty much 4K resolution or 8K resolution recording on the Titan RTX will be the same, look at this, as 4K resolution, the same performance. 4 FPS added to the right top will give you the FPS without the recording, keep that in mind. Heavy volumetric particles, but still high FPS, 15 FPS. This is amazing. This is on a single Titan RTX video card, guys. And as you can see, the VRAM utilization is almost 16 GB. That means that you will need 16 GB of the video card, that featuring 16 GB to be able to run it. So RTX 2080 Ti Turing GPU architecture family not going to be able to run it, or maybe it can manage to run it, but it's going to offload a lot of data from a VRAM into the system RAM, and it's going to slow down our FPS by a huge percentage. I really like that milliseconds latency delay at the right top corner by milliseconds. The lower value is better, keep that in mind, but FPS, the higher value, is better. Below 30 milliseconds latency delay is considered playable latency delay, and right now it's, I would say, playable latency delay. Alright, look at this, there is a bunch of dudes with the RPGs. Oh my Jesus. Oh my god, look at this, the details, the level of details, guys. Every single texture right now is shining over here. And this, again, this is not about the gameplay, so don't get confused over here. This is just a benchmarkable thing. So what I'm gonna do now, I'm going to go ahead and lower the preset. I know a lot of folks that my subscribers is asking to lower sometimes the presets. So this is what we're gonna do, and we're going to rebench it. So let's go ahead and have a look. Maybe just the texture quality. I'm just going to go ahead and reduce the texture quality, but as again, personally I wouldn't lower anything over here, because what's the point to play 16K resolution when you're lowering the texture details and stuff like that, so you ruin that quality. But let's go ahead and have a look. Unfortunately, this game doesn't have a lot of presets to change, but let's go ahead and lower the texture quality and see if the FPS will increase or decrease, and if the VRAM utilization will go down. I'm using only 3 cores, guys, so I shut down the 9 cores in the BIOS and shut down the hyper threading technology, so I'm only using the physical cores, physical threads, keep that in mind. Alright, let's go ahead and restart, and let's go ahead and have a look if it's going to improve anyhow. the FPS and yeah, you can see the quality is bad. The textures are not here, but it's still very high VRAM utilization. So most definitely they didn't improve too much in terms of our FPS, almost none, as you can see. The GPU utilization 99%, so it doesn't matter in terms of the GPU utilization. This is exactly how we want to keep our GPU at 99%, because at 99% we're utilizing all the shader cores on our GPU, and this is exactly what we want to do. We want to utilize it as much as possible, as high as possible. 99-100%, I call it excellent GPU utilization. This is exactly what we want to have. Okay, 30 FPS, not bad, but very bad textures. Keep in mind, as again, this game is running vanilla without any modes, but you can do some modes in this game. Of course, you can have some beautiful modes in this game, guys. Okay, what's going on over here? Here we go. Anyways, so we just saw the FPS, guys, and pretty much the same FPS, but the texture is looking horrible. Alright, let me go ahead and quit it. We don't want to make this video 30 or 40 minutes, and I'm going to show you what kind of system I was running. Again, this video will go unedited. World's Fairs, guys, don't forget to smash that like button for the share. I cannot wait to test it on the RTX 3090. So in the middle, this is my system, how I'm running it right now. This enterprise CPU is cooled with the Corsair H100i Pro, I believe H100 XT Pro. I believe this is going to be the third gen of this type of coolers, H100i. And at the right top, this is my, as you can see, my system, my gaming rig. But as again, you just watch how it's looking on the workstation. This computer is designed to render 8K resolution videos, encoding them, and 3D rendering 3ds Max when every single thread, every single core is utilized, no matter how many cores you have. So this is what kind of monster I had as a workstation in 2020. Will be replaced with the two Xeon E5-2697 V3, not V2 but V3 CPUs, two of them, total 72 threads or 72 virtual cores in Windows, which will be amazing. It's going to be my workstation for 2021, and it's overclockable if you're going to hack the BIOS, and I'm going to hack the BIOS. Hopefully I'm going to share it with you, and hopefully I'm going to beat the 5950X AMD Ryzen CPU. And keep in mind that I got 2699 V3 CPU from the local e-recycle company for $150, $129, and two of them $250, and motherboard from China $150 that I'm planning to hack. But there's going to be more videos about that over the UHDking.com YouTube channel. Go ahead and check it out. So let me show you the resolution. My desktop is set to 16K resolution as well. I'm going to use the Windows magnifier as we already did. So this is what's up, 15,360 by 8,640, 100% scaling. This is exactly how you want to have it. Okay, do not go to 500 if you're running Windows mode, because there is a possibility FPS can be higher and it's not going to be exact 16K resolution. Windows is going to cheat out a little bit, okay, when it comes to 8K resolution and above. So go with the 100% scale. Let me show you, as you can see, this wallpaper image was taken with the iPhone XR. It's noisy. So this is the system that I was running today, and so Xeon E5-2697 V2. V2 is not overclockable CPU, even if it's running right now on a gaming X79 UD3 version 1.1 motherboard by Gigabyte. It's very overclockable motherboard, but it's not overclockable because they lock the multipliers on this enterprise CPU. Otherwise the CPU will be golden, completely diamond. Only 3 cores, 3 threads. As again, why I did it, because when you decreasing your cores in the BIOS, if motherboard is allowing and the Gigabyte X79 GDDR3 version 1.1 motherboard is allowing to lower your core count and disable some cores, when you disabling the cores to 4 core 4 threads only, your frequencies is increasing by automatically hiring the multiplier by the BIOS of any motherboard on this particular CPU, but it's locked. This ability is locked by Intel. So it's running 3.4 when you're running 4 core 4 threads. Otherwise it's running 3.2 with 12 core 12 threads or 12 core 24 threads. Okay. Otherwise it's also because I overclock it through the BCLK BIOS speed. It's running 100 megahertz, but right now it's running 106 megahertz, 6 megahertz additional overclock, which gave me 200 megahertz additional boost, no matter what multiplier, no matter what scenario. So this is kind of cheating overclock, which is cheap, but still 200 megahertz per each core, not bad, no matter what, how many cores you're running. So otherwise it would be running 3 gigahertz with 12 core 24 threads, but it's running 3.2 instead of 3.2 gigahertz, and with the 4 core 4 threads it's running 3.4, and right now it's running 3.5, which is 3497, 3.5 gigahertz per each core. With 2 core 2 threads it's going to run 3.6, and with 1 core 1 thread it's going to run 3.8. But as you saw, based on my CPU utilization, 3 core to 3 threads is probably you don't want to keep lower than that, because you're going to bottleneck your CPU in needs of the cores. And when your CPU is below 90% in the gameplay in your PC game, that means you don't need additional threads or additional cores. But when it's 90%, you can see sometimes it's reaching 90% and above. That means exactly that you need to add the CPU with the additional threads or additional physical cores. Additional physical cores will be better, because the hyper threading technology cores 3.3 cores hyper threading technology will be equal 1 physical cores on this Xeon E5-2697 V2 generation CPU, which is 4000 or 4 Gen Intel i7 generation cores. So hyper threading technology is useless, so I disable that and make sure that I'm running only physical core, physical threads. This is how you want to do it when you're playing games. Okay, and you want to get the instructions in those physical cores, because it's going to compute them 3.3 times faster than hyper threading cores, virtual cores or threads, whatever you want to call them. Okay, cache, here we go. Also cache 30 megabytes only shared between the cores, but 3 cores utilizing about, I would say, 8.7 megabytes per each core. Not bad, instead of just 1.5 megabytes. So the increase in terms of the cache per each core and CPU also going to increase at some certain loads the performance. Motherboard, as I told you, Gigabyte X79 GDDR3 version 1.1 with the F20 BIOS, only F20 BIOS on this particular motherboard, from a Gigabyte website from March 19, 2014, supporting this CPU. Okay, as again, it came version 1.0 and version 1.1 back in 2014. This is version 1.1 with F20 BIOS. Otherwise the CPU is not going to post, it's going to be black screen like computers that. So I upgraded my BIOS, I flashed my BIOS with the i7-4930K that I used back in 2014. That was overclocked to 4.2 gigahertz, but unfortunately it's only 6 cores and 12 threads. So to double my core count, to save the life, and without the recycling my motherboard and my DDR3, I utilize that and using this as my secondary computer, as my workstation. Hopefully guys this makes sense, and it only cost me $129, but I doubled the performance right now, and I saved the life, and I sold my CPU for $90. So it cost me, the CPU cost me only $129 on the eBay used like new in the beginning of 2020. It's only $30 because I sold my i7-4930K. Okay, and it's nice. It's pretty much helping me throughout my 8K resolution video encoding and 3D rendering. 3D rendering tutorial is coming over the UHD King or iPlay16k.com or iPlay4k.com YouTube channels. Is going to be amazing. I'm going to show you how this computer is working while I'm using the 3D rendering and stuff. So DDR3 quad channel. Quad channel means 256-bit, and it's running 4 sticks, 8 GB each, to be able to run quad channel. It's in theory it's 2 times faster than dual channel, which is 128-bit, but in the action, in real life action, it's pretty much 1.3 times faster than dual channel. But still, this memory DDR3 is fast as DDR4, 2133 megahertz. But this memory is running 1130 megahertz. So you got a 565 megahertz times 2, 1130 megahertz, CL7 1T command. Yes, this memory stick is Crucial Ballistics 1866 megahertz CL9, but unfortunately maximum stable frequency that is bootable with this CPU, with this particular CPU, keep that in mind. Other CPUs can boot all the way to 1866 megahertz, but this particular CPU is only booting this memory at 1400 megahertz, and it's unstable. Okay, after 30-40 minutes it's crashing blue screen. So this frequency is only stable without any blue screen, and it totally makes sense because the Xeon E5-2697 V3 CPUs are also very pickable when it comes to DDR4 memory, and it only can run DDR4 memory at 2133 megahertz. Okay, and above that the 2600 series V3 CPUs of Xeon with a high CPU count, core count, is not stable or not bootable. So it's kind of picky when it comes to frequency of the DDR3 or DDR4 when it comes to 2600 series V2 or 2600 series V3 CPUs. And for my, let's say for my two 2699 V3 CPUs, that is very picky, and it doesn't run DDR above 2200 megahertz. Keep that in mind. And it comes with 18 physical cores or 36 threads per each, 36 virtual cores per each CPU. Total, I'm going to run that system in 2021, 72 threads or 72 virtual cores to Xeon E5-2697 V3 on a Chinese motherboard. As again, it's going to be a great tutorial when I'm going to hack it, but more about it over the UHDking.com. Go ahead and check it out. It's going to be a great workstation. It's going to be my workstation in 2021, secondary system. Okay, and as again guys, I'm going to show you how this game runs on a gaming PC. As again, Intel 9 Gen and Intel 10 Gen. Stay tuned. So as you can see, the Titan was overclocked 8000 megahertz on a VRAM times 2, 16,000 megahertz output of the GDDR6, 24 gigabytes. Samsung, same memory is used on the RTX 2080 Ti video card, but as again, RTX 2080 Ti video card, if will be able to handle this particular game at 16K resolution, there is scenario that is going to offload a lot of data from this VRAM into the system RAM, and the FPS will be much lower, even if the RTX 2080 Ti is almost as same in terms of the performance as Titan RTX when it's not overloading its VRAM. I would say it's 256 shader cores less than Titan RTX, but it's like 2-3 FPS less than Titan RTX, so almost hair slower than Titan RTX. But anyways, this is how the CPU benched. As again, the CPU Z doesn't see 3 cores, doesn't see 5 cores, doesn't see 7 cores, so it's kind of benched 2 core 2 thread. As you can see, it benched excellent, a 2.0 ratio. Okay, and as you can see, IDA64 GPU benchmark when using the OpenCL API, bench the GPU versus the CPU. This is the only API where we can bench the GPU and CPU and find out how fast a GPU Titan RTX TU102 a Turing GPU architecture by Nvidia versus the Xeon CPU. Okay, and also over here IDA64 cache memory benchmark right here. So when I'm using CL7 and running 1130 megahertz, my latency delay below 94 nanoseconds, and the low value is better. So the lower value is better. When I'm using CL9, it's going to be above 100 nanoseconds. So it's kind of a little bit faster just by the latency delay, but unfortunately I cannot go above that frequency. Okay, not bad, 29% overclock and this is not overclockable CPU, but using my methods and techniques to the BCLK, as you can see, base frequency, additional 6 megahertz boosted up, and then by lowering the CPU cores in PC games, because we don't need that much CPU cores, as again, when CPU is not loaded at 90% and above, you can lower down your cores to that scenario when it's going to be below 90% in your PC games during the gameplay, and you're going to be Gucci. You're not going to lose any FPS, guys, because each core can receive like up to 1000 virtual threads on it. Keep that in mind, and it doesn't matter if it's going to be core 1 or core 2 and they're going to split those virtual threads, it's still going to be the same performance, okay? But it matters when you're going to go above 90%, most likely Windows will be lowering your FPS just to make sure that you're not going to overload your CPU cores and you're not going to go all the way to 100 and above percentage, and it's going to predict automatically after 90% on overall CPU load to make sure that you're not going to overload your CPU cores and you're not going to bottleneck just because the CPU cores. All right, pretty much self-explanatory, explain to you everything what you need to know. As again, what I'm going to do about right now, I'm going to bring the Titan RTX to stock, just going to show you what the overclock gave us, but keep your eye over here at the pixel fill rate, 179 gigapixels, textual fill rate, 538 gigatexels, and bandwidth 768 gigabytes per second. I'm going to bring the Titan RTX to stock about now, boom, and you're going to see those values going to decrease immediately. See that? Pixel fill rate 169 gigapixel per second, textual fill rate 509 gigatexels per second, and bandwidth is 672 gigabytes per second. Okay, pretty much that's how it is, guys. And as again, you want to enable all the cores when you're going to use it as workstation, but when you're playing games, and if you're going to build something like that as your all-in-one system, low budget system, then go ahead and games, lower the core down, disable the hyper-threading completely, and just to use the physical cores, and if possible use the 4-core 4 threads for the great boost. And if it's not possible, just use the 12-core 12 threads, but without the hyper-threading technology for the maximum possible boost. This is what I learned about this CPU. But if you don't have the X79 motherboard for the Socket 2011, then if you want to build something like that, enterprise CPU, pick up cheap used like new on eBay from a great seller with a lot of stores, then I advise you to go ahead and grab yourself V3 Xeon E5 CPUs, because V3 Xeon E5 CPUs are overclockable through some BIOS hack. It's requiring some IT knowledge, but I'm going to explain to you how to do it, but it's overclockable when the V2 CPUs are not overclockable, and multiplier is going to be automatically controlled by the BIOS of the motherboard and by the Intel CPU and Intel logics. Okay, well, that's it, guys. That's pretty much it. Thank you so much for watching. Right now I'm putting some great videos for you to check out. Check right now on the screen or in the video description or in the comments. Don't forget about the positive comments to motivate me to record more videos. Smash that like button, subscribe, and I will see you guys in the next videos. Stay safe, happy holidays 2020, Christmas and New Year, and I will see you guys in the next videos. I play 4K, AK I play AK, AK I play 16K, or UHD King. You just watched the world's first Call of Duty Modern Warfare 2 16K resolution video, 133 megapixel render in real time. This is amazing, and Titan RTX is the first video card that allow us to bench it at almost playable FPS. Till the next time.